Hello, welcome to today's episode on voice parameters in Parkinson's disease. We have made a literature search of voice parameters used in Parkinson's disease. We are not focusing on speech, which includes rhythm and tempo, linguistics and vocabulary. The literature search were made in two parts. The first includes vocal biomarkers and artificial intelligence, all up to 2023. The search were made by the Royal Society of Medicine Library. In all, there were 332 papers, of which 54 papers included Parkinson's disease. The second literature search was made based on the first one from 2013 to 2023. Before 2013, there were only scarce results, and it included specifically voice parameters in Parkinson's disease. 98 papers were found. On this picture, we show an Excel sheet, 47 papers with voice parameters in Parkinson's disease from 2013 to 2019, 4 including AI. First, we organized the papers if they were prospective, randomized, case control, and retrospective. And then we ordered them as far as HNR, SNR, F0 plus standard deviation, intensity, and MPT, which means harmonic to noise, signal to noise ratio, fundamental frequency and standard deviation, intensity in decibel with standard deviation, and maximum phonation time. Thereafter, jitter, absolute and percent, shimmer absolute and percent, spectrograms, long time average spectrograms, septrums, VRP, which means voice range profile. We also divided them in whether it was a telephone or with analysis program PRAT. As for various subjective tests, VHI, meaning Voice Handicap Index, and GRBAS, meaning Global Roughness, Breathness, Asthenia strain test. We also included deep brain treatment, deep learning, and other artificial intelligence tests, and noted whether a laryngoscopy was made. Here we have 51 papers with voice parameters in Parkinson's disease ranging from 2019 to 2023, 20 including AI. The reasons for the division in 47 and 51 papers is that after 2019, there was a huge acceleration in papers with artificial intelligence, especially with deep learning. It makes differentiation a little difficult that the voice analysis program PRAT has an analog and a digital part. This validation is based on 7,561 patients, 23 papers without numbers, and 1,513 controls, 58 without numbers, in 98 papers from 2013 to 2023, minus 5 reviews. Most studies are on early and moderate cases of Parkinson's disease. 7 papers present results of deep brain treatment. Mostly, validations in non-AI papers are HNR, harmonics to noise ratio, F0, fundamental frequency, intensity, jitter, shimmer, and VHI, Voice Handicap Index. Also, in non-AI papers are SNR, signals to noise ratio, MPT, maximum phonation time, spectrography, septrum analysis, VRP, voice range profile, GRBAS, global roughness, breathness, asthenia strain test. PRAT is used in both non-AI and some AI cases. AI is used for validation in 24 papers and is often based on many more parameters. Unfortunately, these parameters are more or less arbitrary and in most cases without evidence. Included in those 98 referred studies were Lesion and co-workers who showed voice quality outcome of idiopathic Parkinson's disease from 1980, 106 studies, here of acoustic testing in 27. The methods varied substantially. Pino and co-workers, impact of levodopa treatment in the voice pattern of Parkinson's disease patients. A systematic review and meta-analysis. Impact of levodopa treatment in the voice pattern of Parkinson's disease patients. A systematic review and meta-analysis. Chiramonte and Bonfiglio, acoustic analysis of voice in Parkinson's disease. A systematic review of voice disability and meta-analysis of studies. Pu and co-workers, voice treatment to improve speech in Parkinson's disease. A systemic review and meta-analysis. An increase in semitone standard deviation was found. When it comes to machine learning studies, there is a big variation. This indicates that much tighter co-work between researchers is necessary to get usable parameters in the future. ML stands for machine learning. It was noted there was a great variability of features. Another comment is that Pratt has two systems, one with and one without machine learning. We considered 6 papers as being machine learning related. 2 reviews and 1 smartphone analysis. The 2 reviews included Alpers, Idrisoglu and co-workers applied machine learning techniques to diagnose voice-affecting conditions and disorders. Review of voice as biomarker analyzed from 2012 to 2022. 145 studies were included where support vector machines were used in 35%. The most studied disease was Parkinson's disease with 60%. Nearly 50% used 10 distinct datasets. The problem is limited and unbalanced dataset usage in many studies. Ngo and co-workers, computerized analysis of speech and voice for Parkinson's disease. Review from 2012 to 2021 of analysis methods and signal features, datasets, recording protocols, signal analysis. Values of features that separate Parkinson patients from healthy controls were focused upon. Large differences were found between datasets. It's very interesting to see that already in 2022 and 2023 there are reviews about Parkinson's disease and artificial intelligence. Another interesting aspect is telephone interviews, and here we show you one of the most interesting ones. By Urasawate and co-workers, classification of Parkinson's disease from smartphone recording data using time frequency analysis and convolutional neural. 4,051 patients from the largest mobile Parkinson's disease studies, Empower study, was used. A dataset comprising of 385,143 short 1-second audio samples of RR is presented. The samples were converted to spectrograms. CNN models were applied to classify. Conclusion of our search of voice parameters in Parkinson's disease. Non-AI shows effective, clear differences in the measured parameters compared to healthy controls, but mostly the studies are not comparable. The results were not compared with other disorders. Quantitative validation of the single parameters can be done by comparing early, moderate, and heavy Parkinson's disease to healthy controls at best, also to other disorders. The artificial intelligence studies had a large variety. A third of machine learning papers use support vector machine learning. Well-defined features and datasets are essential in the future to measure quantitative deviations of voice in Parkinson's disease. Is Pratt a possibility? A Washington Post journalist asked us to validate a paper with the given title of Sequence Variants Affecting Voice Pitch in Humans. They evaluated voice pitch, vowel measure, and aggregated vowel measures related to 39.2 million high-quality genetic sequence of variants detected through whole genome sequencing of 63,460 Icelanders. They found variants ABCC9 associated with voice pitch. Please consider the following information with a degree of skepticism. We have tried to dig down into the alleged biomarker used in this paper. The first problem met is that they used too few voice features. The second is that the ones they used have no clinical trial reference. The third is that there is no common agreement on which biomarker to be used in a new area like genetics. The considerations show how important our group of biomarkers, led by Mieke Mørman in the Union of Phoniatricians, is to establish a fundamental reference frame. Thank you very much for listening.